Hello guys, today we will continue our scenario. In first BGP session, I show you how make a neighborship between two AS by a neighbor command, and then after that we add this route 9992 by the network command in BGP and otherwise in this router. And if we go in R6 and for example say show IP BGP, you can watch we have the route 9992. It shows that next hop, it means 3331 is this interface. Learn from here and learn from the AS of 65,500 or AS, our organization that we are working. And if you check it, I told you, you must always check. The route must be valid and best, both condition to go in RIB. If one of them not valid, it will not go in RIB. And if you get show IP route, you can't find it. So this is always important. Check it. Today we want to config AS 15,000. Here all the connection I make it IBGP. Then I want to show you which kind of the problems happen. Then we will talk about all these subject, next hop, peer groups, configuration, load reflector, and roadmap. I write a roadmap and show you how to work. Just again, I remind you, eBGP, the TTL is one, so it is just TTL from one interface go to the next interface. But in IBGP, TTL is 255. It can continue, but there is some issue and some problem. I write here also again remind you about we have public AS and private AS. This is like a IP address. We have private IP address and public. The private AS cannot go through the internet. It is just inside the AS. You can make it. Then I will tell you private AS in configuration. We can use it. Okay. So we will start to make the neighborship between these routers by IBGP. So in R6, just check it, show IP interface brief. And here R8, show IP interface brief. You can see in R6, giga01, and the IP address is 10.1, and this one on R8 must be 02. Okay, so in R6, I will start to go configuration, then router BGP. Here the AS is 15,000, so I make it 15,000. Then neighbor, I want to make a neighborship between two routers. So what is the IP address of R8? We check it. It is 192.168.1.10.2. 10.2. Remote AS, we are all in 15,000, so it will be same. Okay, so now we make a neighborship between these two. And now I want to show you something to understand. Look at this router R8. R8 connect to R9, connect to R7, and connect to R6. For these routers, just we need one-time configuration, connect, and show the neighbor. But this router has three neighborship. So we make the neighborship for R7 and R9 for R8. Then we go in R8 instead of anytime when setting config it. this one and this one separate, this one separate, this one separate. We make it peer group. I will show you, make a group. I add this kind of neighborship in a group. Then anything that we want to add, for example, some policies, some things we want to modify, because we will run for all of them. Same time we can in peer group do it for all the routers. So now I make the relationship in R6, then I will go in R7. I check show IP interface brief. R7 gig is 01. You can say gig 01 is 5, so the neighbor is 6. So I go in router BGP 15,000. Then I add the neighbor 192.168.10.6 remote AS 15,000. Also in R9, I go in the configuration, then router BGP 15,000. It's better get a show IP interface. Here is Giga 00. I must write interface brief. I must just show IP interface brief. Giga 00 is 10.9, so the neighbor is 10.10. Okay, conf router BGP 15,000, neighbor 192.168.10.10, remote AS 15,000. So we config R9, R7 and R6 and introduce the neighbor. Now we will go in R8. Config router BGP 15,000. Now we add the neighbors. Here the neighbor, it shows in R8 we have 2, 6 and 10, so then other neighbors is 5, 1 and 9. I add 192.168.10.1 remote AS 15,000. Next will be 10, 9. It will be here, and the next is 10.5. Just next, look, now the neighborship up. I make 10.5. So I introduce the neighbors by remote AS. So all the neighborship is up to 10.1, 10.9 and 10.5. So now we make the neighborship IBGP between them. If I want to add anything, any policy or any configuration, if I want to do it one by one, it will be difficult. So I start to make a peer group. So I make a peer group. I write a peer group IBGP. Let me show you. If I, after neighbor, I make a question mark, says that you can say neighbor tag. So I write a name. I make it IBGP. IBGP. Okay. Uh, and after that, you can define peer group. Sorry, my system is very slow. Uh, Here, peer group. So after this command, I write the name. I make a name of IBGP. The group name is IBGP, and I make it peer group. It means that make this peer group for me. The last thing that I must do it is I introduce this IBGP, the name, the group, say that I must use capital, same. This group belongs to which AS? I says that 15,000. When I do this one, all the neighborship that is by remote AS, they will come in this group. So all these three, the relationship of the neighborship, all will go in this group. Then I will show you how can we use this group. Let's check the routes in R9, R8. In R8 we have two loopback. Let me add them in our BGP. So I write network 80, 80, 80, 0 with the mask of 255, 255, 255, 0. This is /24. The next network, the loopback is 88. I add 88, 88, 88, 0 with the mask 255, 255, 255, 0. Okay. Also, we add the loopback 999 in R9. So I will be back there. I go in address family, IPv4, and by network, I added 9999, and this is I forgot to write this /32, so I add 255, 255, 255, 255. Okay, now let's check the route in R8. Show IP BGP. Okay. Uh, we have 80, 80, 80, 88 route and 80 route here. The R8, we make this route inside it. It is locally. So we can see it is valid and best, but it shows the next hop 000. Because it is locally, this route is locally, it didn't come from another route. So anytime you see some routes, the next hop is 00, it means that this route is from the inside the local of the same router, not from the other routers come. This is the first thing you must learn about the BGP routing reading. And also, if you are using the Cisco routers, this attribute belongs to the Cisco, the weight, and the weight in the local is 32,768. So this is the way that you can learn and understand about it. Now, forget this one. I will explain you later. Now I want to work on this. Look at the 9992. 9992 came from this route to this route. Okay. But if you check the next hop shows 333. It shows the interface of here, not the interface of here. This is the problem of IBGP. When IBGP send a route to the next router, it will not update the next hop. And this next hop, it is for the previous route. We must fix this problem. And if you see, it's not best. It is just valid. It shows there is some route, but it's not best. And if we check it in show IP route, we cannot watch 992. If I write it show IP route, you can say we don't have any 992 because it's not best and valid. This is the matter that you must remember. Next hop self. Sorry, just okay. Uh, we must for all the BGPs run the next hop self in all the routers that we are using in IBGP. So I will go and config from R8, R6, R7, and R9. So I am going in config router BGP 15000. Then I will go in address family IPv4, IPv4. Then say that neighbor. Here the neighbor, the interface is 192.168.10.2 and active next hop self for this route. It means that any route you learn, send for this router, but update the next hop. Shows your interface, not the interface before. Let's see. I make this one. Say it shows that make it in peer group because now we set a peer group. We can do it by peer group. Neighbor IBGP. Okay, I write the peer group and same time I will send this command for all the routers from R8. IBGP next hop self. This is the benefit of the group. Just one time I add this one, automatically send for all these routers this update and this configuration will happen. Now I will go in R6. In R6 also we need to add it. So I will go in IP address IPv4, then neighbor. The neighbor of R6 is 192.168.10.2 and next hop self. I active. Then in R7, in address family IPv4 neighbor. The neighbor is 10.6. 192.168.10.6. Next hop self active. In R9 also we are in address family, so just I write it neighbor. The neighbor is 10.10, so I write 992.168.10.10. Next hop self. So I set next hop self in all the routers. I did it here by peer group in R8. Just one time I add this command in a group. So update all and one by one. Now let's check in R8. If you check before, it shows 9992 comes from the next hop 333, but 333 is between these two routers, so it's not valid for here. This router didn't see any interface of hope from this router by this address, so it will not be valid. Now we update it and says that okay, when you send a route, update you the next hop updated by your interface. So this interface must be changed and this route must be valid. So again, if I go and say that make a show IP route, show IP BGP, sorry, I think we need to just update clear IP BGP store soft soft. I do this one on R6 also. Okay, now in R8 we get show IPBGP. Yeah, take a look. It is updated and yeah, see the source changed. The next hop changed. Before the next hop, where is it? Sorry, in IPBGP. The next hop was 333. Okay, and here you can see these two routes shows come from these two R6 and R7, but both of them the next hop was 323. Now we active the next hop self, so they change the interfaces to that interfaces 10.5, 10.1. It shows it come from this interface and this interface. Now this route is valid. Okay, and it shows for 992 we have two way, but we don't have a load balance in BGP, so just one of them will be selected, and BGP select this one for the best route and that one will be like a backup. But now the source updated from both of the side, so everything is good. Now let's go and check these options on R9. So we have 992.800.888, and after that in R9, let's check show IP BGP. Okay. Oh, here I make a mistake. I must mask to add this IP here in the route of R9. Let me do it. Router BGP 15,000 address family IPv4 IPv4, then network 9999 with mask 255 255 255 255. Sorry, I make a mistake. I forgot to write this mask command. So 999 it's not comes inside the route. Now again I get a show IP BGP. Okay, we can see 999. It shows next hop is 00 because this loop made by the router in it is locally. So next hop and the wait also show you this is locally in route. This route learn R8, just these two routes, okay, 80 and 88. But what happened about the 9992? In R8, in route, we have 9992, okay? We have this route, 9992, but we can't see this route in R9, okay? This is the problem that we have with IBGP. Let me explain you. Uh, make the color. Think that this is my house. This is our neighbor house. When I send some message to them, for example, I send this one. I send a message to this neighbor, say tomorrow is snow comes, and these neighbors also tell to this guy that the day after tomorrow is sunny, and so on. Okay, when I give this information to this neighbor, and this neighbor want transfer my news to the other, says that okay, uh, for example, my name Kami or this is AS number. Kami told that tomorrow is snow comes, and I say that the day after that it is sunny. So each guys that send some update, it give that who give this address, who give this information. It is the name or AS number like this. So anybody understand it. If this neighbor come and says that Kami told that, I said that I am Kami. Why you give this information? I told this information before, so it will not accept this news because I know I was the source of that address. Okay, this is that happen in EBGP. We have AS number, but how about IBGP? In IBGP, we don't have any loop prevention. So if I send a route to the next route, it's fine. It will send it, but it will not update the route of next hop. I update it by the command of next hop and says that, okay, correct and update here. But after that, this route says that I cannot send this route to the others because there is no loop prevention activated. Maybe this route get the information, give it to this, again come back here. I don't understand it. What is the main source? Because we don't have any AS in IBGP. This is the problem of IBGP. So what shall we do? There is a two-way that we can fix this problem. The first way is says that configuration. You can make each two routers like a group. So I make this one like a group of sub AS. I make a sub AS. This is that the location that we must use private AS inside it because it's not routable in internet. It is just for the inside. We set a one sub AS, private AS for these two routers. Then we make a sub AS for these two routers and make this two routers sub another sub AS. So each group has a sub AS, and when they send some route information to each other, they know where is the source. This is confederation. This is the technology as confederation. It's not easy for configuring the configuration. It is difficult. And now hopefully we have another configuration. It is route reflector. In route reflector, you must think about the you are in head of a tree. It's like a tree. You send a update to the others. So you need to configure route reflector in the router that send have so many connection between to the others routers. I made config here the route reflector. The route reflector come and send the update, but make a cluster ID. Cluster ID, you can think like a, I write it here, you don't forget it. Cluster ID made by route reflector. Uh, Sorry, made by route reflector. Okay. So when we active the route reflector, it make a cluster ID, and this cluster ID when send a update to this route, send update to this route, send update to this route, set as cluster ID. This cluster ID is like AS, so we can make a loop prevention by this way. Let's go and check. Before run the route reflector, one more time again we check it. In R9, we don't have 992 because this route says that I cannot send this other route that comes from the previous route because I don't have any loop prevention and I don't allow to update. When I active the route reflector says that don't worry. I make some cluster ID so I can transfer all the routes that we learn to each others and send to all the clients. Now I am going in R8 in conf router BGP 15,000, then address family v4 and says neighbor IBGP. I set it for the all the peer group of here. Uh, route reflector client. So I active on R8 route reflector client for the group of IBGP, this group that I make it. And now let's check. Now I am going in R9 and get show IPBGP, and yeah, you will see 992 added here in R9 because the route reflector now it is active. Before we don't have any 992, it was just these three routes. And after that we active the route reflector, we can watch 992 advertised to this route. I tried to explain too much, I know, but just this is the matter that you understand it carefully. Now take a look. If you look at 992, you will understand it that it is valid. Now shows valid, but it is not the best. Here shows valid, but it is not best. So it's not coming, in fact, in our route also, if I get show IP route, in IP route I can see 992 because it's not best and valid. It is just valid. And you know the problem. The problem is because it's not updated. It shows the uh, interface of here 10.1. It must shows the interface of here 10.9. So I must for this one by next hop self for the first route it was okay, and by next hop self we solved this problem. But from the second to third we need to write a route map and set this interface for this route. Says that any route that you send it, update the source, make your peer address shows gigas02, the IP address of that. Then when this interface change, this one will be best and valid. I will show you how to can we write it. So I'm going in the conft and I make a roadmap. I make a roadmap and then name next hop. I make it next hop. Okay, and say in this roadmap set the IP address uh, set IP sorry set IP for next hop. Okay, says that when you want get any route in R9, I says if you want get any route comes to you, go and set all the address to the peer list that you get it. It means that set IP address of giga02. I write this roadmap to update and change this source, any route that comes for that to the this interface and the IP address of here. So you will see after that I will go out and now I must active this route map in my BGP. So I'm going in router BGP 15,000 address family IPv4, and I says that okay for the neighbor 192.168.10.9 10.10 sorry, the IP of here is 10.10. For the neighbor of this set a road map, active this road map in R9. The traffic, the road comes inside the router R9. So I make it this road map, the name is NH. I tell that which side, I said that when the road comes inside R9. Okay, I make it in. And now if we go and check it, it must this roadmap work and 992 will be best. I think we need just clear, sorry, clear IP BGP star soft. Do the update. Again, get the show IP BGP. Yeah, see, before it wasn't best, now it is best. What was the IP before? It was 10.1. It shows the interface of this interface and this in these two routers didn't understand this interface. because just these interfaces between them is important. And now the interface updated, it shows the giga02, the IP address of that. So this route now 992, it will be valid and best. Same vice versa. Think about 999. 999 goes in R8, it is fine. It will be valid and best. But from R8, we active route reflector send it to R6. But in R6, 999, it will not be best. We must set in R6 and R7 also same roadmap like this. Let's check, just verify. If I get show IP BGP, now you can see the 999, the route is not best. Sorry, 999, you can watch it. It is just valid, it's not best. Because after the second route, you need again write a route map and make this one valid. The interface, it shows 10.9 from here. You must update the interface to this IP address of giga01. So again, I write just a practice. I write a route map again. Route map. Again, make a name. Next hop. Okay. Then says that set next. Set the next. Set IP. Next hop. Pair this address. Okay. I will go out and go in router BGP 15,000 address family IPv4 and says for the neighbor here the neighbor is 10.2 192.168.10.2. Okay, route map. What was the name of the route map? NH. What is the site? 999 come inside R6, so I make it in. Now let's go and check the show IP route, show IP BGP. And I needed to update it just to make it clear. IP BGP star soft, because BGP is a lazy routing protocol. It takes time to update, so manually I do it. Again, show IP BGP, and you can see now 999 updated to the source next hop 10.2. It means the interface of here, and now it is best and valid. Before 999 was the interface from 10.9, it shows here, and it's not valid. I explained all the subjects just for your reference to understand it about the route reflector. I show you something. I go in R9. If I write show IP BGP 9992, because this route comes here and by the route reflector advertised. If I click here, you can see this option, cluster ID. This is the matter I told you. When advertise 992, then after that we activate the route reflector, start to make the cluster ID, and this cluster ID, as I told you, it is same function like a AS. So like a AS, we have the address, we know the source from where originated, and then no loop can happen. This is all the information that for this course you understand about IBGP. I hope the information be useful for you. Have a nice day and enjoy.